Juverly, and we're going to be working on a Evan of Code problem from 2020, one that I haven't worked on yet. So as we can see here on the list, that would be number 13. And the idea here is just to give you an idea of problem solving, I suppose. So the first thing I'm going to do is I'm just going to go ahead and copy all of this text into my editor here into the project on the left, including the examples, and that way we can get more screen space. So this is probably the example data. Every problem typically comes with some example data, so I'm going to go ahead and put this in a file. Then this down here as well. Make a note. See example file. So we'll call this, well, we don't know what the data is yet. I mean, so I'll probably end up wanting to rename the file at some point. We'll make it a txt because we don't know what it is. I mean, even if it isn't something that needs to be in a file, it being there won't be a problem. Okay, we should be able to, oh no, we need the puzzle input as well. So this is just some bookkeeping that I know we have to do for these types of problems. And that way now we can get this off our screen. Okay, so now my strategy is to sort of read through the problem statement, and we want to really cut it down to the core problem that we're going to have to solve, though we might have to refer back to the web page if we take out something that later then leaves us confused, but we should hope to walk away with just the core elements here. There's always like a storyline that we don't care about. I mean, in terms of solving the problem, maybe in terms of the names we end up using. Your ferry can make it safely to a nearby port, but it won't get you much further. When you call to book another ship, you discover that no ships embark from the port to your vacation island. You'll need to get from the port to the nearest airport. It's not relevant. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Okay, each bus has a number ID that schedules how often the bus leaves for another airport. That also indicates how often the bus leaves for the airport. Okay, so the ID is dual purpose. I'm going to write that as a question. Also sort of emphasize it to you what I'm thinking about, because right here it says the ID number also indicates how often the bus leaves for the airport. So it's the leaving time as well as the ID, which is not a good way to model your data, but I suppose it's possible that's what they've done. So bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. Okay. At timestamp 0, every bus simultaneously parted from the seaport. After that, each After that, each bus travels to the airport, then various other locations, and finally returns to the seaport to repeat its journey forever. So they mean it goes in a loop. So they all left at the same time. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport. It's not clear yet if they all go the same route or random routes, but it seems as if they all start from the seaport and their first destination is always the airport. So what I mean is like so at like time 0, I guess, if time is maybe this dimension right here, time, and 0, and we'll call this like t1, or just 1 because we've already labeled the time, and then 2, they all start at the seaport, and then they all go to the airport, and then I don't know how I would draw this, but essentially we don't know if at this point they're all going to different locations or not. The time this loop takes a particular bus is also its ID number. The bus with ID 5 departs from the seaport at timestamp 0, 5, 10, 15, and so on. So it takes the time is also the ID. Okay, the bus with ID 11 departs at 0, 11, 22, 33, and so on. If you are there when the bus departs, you can ride that bus to the airport. Okay. I don't know if we're going to end up having to care about these other locations. I think we're just going to need to care that we, what's the next bus that'll arrive. Though I guess I'm also interested why it would matter that we would figure this out, because it seems like you'd have no choice. You'd simply wait, right? Practically speaking, it wouldn't matter what the next one was. Your notes, your puzzle input. This all seems relevant information. I'm not sure I can cut down. Your notes, your puzzle input consists of 2 lines. The first line is your estimate. Here, let's pull that up. In puzzle input. And then also the example, because I assume the example might be easier. Though now that I see these differ so much, maybe this isn't the exact same format, obviously. So that was optimistic of me. So we're looking at the bottom right one right now. The first line is your estimate of the earliest timestamp you could depart on a bus. Okay, the second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. Okay, so the first one is like the time I think I'm going to arrive there, which he says estimate, but I assume we'll just take that as fact for the purposes of this problem. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly 1 such bus. Still not clear how you're saving time by doing this, because assuming they all come to the same spot, you would just take and they all go, the first one goes to the airport, you would just get on that, whatever one was there. It wouldn't save time, it would just be a thing to know which one it's going to be. For example, suppose you have the following notes, 9, 3, 9, 7. So this is when I think I'm going to arrive, and this is these are the bus IDs / times that they the length of the loop that it takes for them to get back. So for instance, the 7 right? Like we said before, ID 7, I guess we'll call it time loop for short. If it's 7, doesn't need to be squiggly. Then the other ones are going to be 14, 21. So basically, if I remember my math notation correctly, it's n equals, and then 7, something like this. Oh, I guess it's up to infinity, right? I was putting that number there. And then really what I want is n2 equals n1 plus 7. I think that's how you notate summation, though it's been a hot minute. I'm going to erase that because it probably won't be useful. Here the earliest timestamp you could depart is 939. Oh, and we already went over that. And here's the answer. The earliest bus you could take is bus ID 59. It doesn't depart until timestamp 944. So it would take you, so you would need to wait 944 minus 939, 5 minutes before you departed. Multiplying the bus ID by the number of minutes you need to wait gives you 295. Why are they doing that? Multiplying the bus ID by the number of minutes you need to wait. What is the ID of the, and here's the question, what is the ID of the earliest bus you can take to the airport and multiply the number of minutes you need to wait for the bus? Okay, I guess they're doing that. I don't know why we're multiplying it. Maybe that makes it harder to guess or something if you were trying to brute force. Oh, right, because you could just submit all the IDs or something. Yes, because otherwise you could just loop through all the IDs and submit them. All right, we've read the problem statement. I'm gonna go take a quick break and be right back. I'm back. So, trying to think as high a level as I can about this problem. It would seem to be the case that what we have here, but certainly what I can say for certain is given a set of numbers n, let's just say a set of numbers that we want to find the min of n. So in this case, we need to be more clear about what n is, right? Because it's not just a set of numbers, but it's going to be the distance, I suppose, between two numbers, or the difference. We'll say difference between let's say start and end. So start is always going to be the same, right? Because start is always going to be, in our toy example, 939. So the notation on the right here is going to get probably sloppy because I'm not sure where we're going with this, but I'm going to call start S, and that's always going to be 939. And then we'll call E for end. And for the set of n numbers, that would be, I guess, just a set of numbers, really. And then in pseudo notation, n is this set of s minus, we'll call E, lowercase e for like an individual number, E1, and then a comma, and then S. It's E2, and then a comma, etc. And then again, we want the min of that. Oh, and then but e isn't what we're given. What we're given is, we'll just denote that what we're given, y, the set of numbers. We're given y, which is, how do you describe, I sort of know what we want to do, but I'm curious if there's, because y is both the first time, it's really a function. So we're given a set of functions. Y, and the function is just that number repeated over and over again. I don't know a word for that. Not repeated, but added to itself towards infinity. I mean, it is the summation function towards infinity. So we can definitely describe this pretty easily as a math problem, though it's possible we could just code it without doing that. But I'm guessing here at problem number 13, we're going to be running into performance issues if we go the other route. And also, abstraction-wise, usually understanding the math principle goes a long way to simplifying the problem. So the question is, hold on one second. Dog out. So I think intuitively, we know that we don't want to check every single iteration of a number getting added to itself, 7, 14, etc., in order to determine against all the other ones which one is the smallest difference. So it'd be nice to be able to use the set number. We have the constant number that we're given. And I feel like, well, how do you know? Because if we can identify what numbers would be multiplied repeatedly to get close to that number. So if we took 939 and we said, like, what would we multiply by itself over and over again? Not multiply, but add to itself over and over again. What number would we add to itself over and over again to get close to that number? That might be how we should think about this problem. So let's make an even smaller example really quick to see if this sort of helps me think about it. So if we are given let's say the numbers R set E is 1, 2, 3, and our start, what I've called it, is 4, then I think it should be obvious that the what we'll call the E star, which is like the min, E star is going to be equal to the min of S minus E T for all, where T is all. Where T is any member of E. Again, this is like pseudo math notation, so if any mathematicians are watching this, like, forgive me. Oh, and we know that this is also going to be equal to 2 because 2 plus 2 equals 4. So and then thus 4 minus 4 equals 0. So the min would be 0 as we're, I guess 1 would work too, right? In this example, so I'm going to get rid of 1 because we could get to 4 via 1 as well. But 3, the other option would be 4 minus 3, which equal 1. And the min of, well, we'll do it right this way, 0, 1 is obviously 0. So the question is, in sort of like the mental process or mathematical process here was to notice that 4 is divisible by 2. How does that help? Oh, 4 is divisible by 2, and also 2 is divisible by 2. And they would both have mod 0, right? Is that right? I'm going to use my, sometimes I'm going to check it really quick to see if mod is what I'm thinking of here. The editor's not helping me. Do I have a CytoRipple running? I do. Number 4 and the 2 is divisible by, and then 4 and 4 is obviously was that what I was thinking of? That they're both divisible by 2? I think what I'm trying to think, is it the greatest common divisor? That would be the, because if you have the greatest common divisor of both, like if I find the greatest common divisor of E and that's available, then that should be or it wouldn't even have to be the greatest common divisor. So for instance, the greatest common divisor of 6 would be 3. But if you chose 3 and 2 is available, you'd be wrong. So the least common divisor, because that would be 2, and so 6 would be right on. What would be one with the least common divisor of 12 would be 2 again. So let's say our number was 13 and we had well, no, 1 would defy all of these, right? Because if 1 was available, you would always choose 1, and the least common divisor, I guess, isn't 1 the least common divisor of every number? The other option is to try to brute force this, right? Because we'd have to, okay, let's drop trying to be mathematical for half a second and really play out the other side of this, which is that if I was just writing a brute force method, then what I would do is I'd iterate over, I'm highlighting on the Emacs here. I don't know why it's given us these X's, we're just gonna have to filter those out, but so let's say 41 and 37 are the first ones that appear. And so I would just keep iterating until I got close to that number, right? And then I would say, what's the difference between that and, oh, it would have to be the one before, not the one after. So you would iterate until you got to a number greater than this number, and then you would record those and you would just take the differences. You know, I mean, especially because that can be parallelized, I don't think there's any harm in doing that as a first try and then seeing if that's fast enough. So concretely, I'm saying that, like, since there's no performance requirements here, if there is a clever mathematical way to do this and I'm not seeing it, I'm currently okay with the trade-off in this of eating in some CPU cycles in order to get the first problem correct. So let's try that really quick, because I don't think that'll be too hard. So we know that I'm just going to create the, what is it, our leave time. Leave time is 939, and what are these? Estimated bus IDs. I don't want to call them IDs because that's sort of not what we care about. Bus leave cycle times. Here's it. I don't know the word for, because they're functions. Cycle functions. Cycle times. Yeah. And I'm just going to pull them out. I don't need commas. 13, 15, 9, excuse me, 31, 19, 19, and do I want to make this a for loop? I feel like typically, okay, so we know we want to, it's easiest to break this down into pieces, and I think the first piece is definitely to map over each one of these bus leave cycle times, and we know that we want to get the number before, we want to get to the point where it's over that number, right? So we're going to map over the bus leave cycle times, and what we want is, so I'm going to call this CT time, and then how would we continue to increase until it gets to a certain point? I guess this would be a reduce, right? I'm trying to think of another way that this could be done. Just because a map, or reduce inside of a map, is ugly. I mean, this could go back to the for loop, but no, a for loop wouldn't work because we're accumulating over the number. Yeah, reduce is the go-to when you don't know what's happening. Reduce. And then hopefully this can be really small though, because we definitely want to start with 0 and CT. Well, we're starting with the CT, I guess, and 0 is implicit, and then we're going to so if this the number is greater than the leave time, or equal, I suppose. So this isn't going to be quite right because I'm just going to return it right here. So we want the one before it. Oh, then we would do reduced this number. Otherwise, CT plus the number. Right, let's make this really small, so I'm not dealing with just for a moment, put this up here. Don't know how to create an iSequence from Java long. Is reduce the right? I don't use reduced very often. I'm gonna look at the internet really quick because that explanation wasn't 100% clear to me. I think those are the LSP. Or, you know, I think I can get CIDR docs on here. No, that's the right function. I'm probably not doing myself any favors by trying to have the formatting this way. And also using anonymous functions. It's creating like a little bit more overhead. Than I need to deal with. So we're starting, so there's what we have here is like a total, I guess. And if I don't think like this should change anything. You know, really quick, let's pull this out. Let's just write this function by itself really quick with a toy example. So let's say we start at 0 and it's not a sequence.